Hi students, in this video we are going to study the classification of embedded system. The embedded systems are mainly classified into two categories. First one is based on the performance of the microcontroller and second one is based on performance and its functional requirements. Before we discuss the different categories, let me discuss a simple question. Can the same microcontroller be used in a calculator, a washing machine, and an autonomous car? The answer is no. Why? Because the processing speed, memory, complexity, and performance requirements are completely different for each application. For this reason, embedded systems are classified into three categories. First one is small scale embedded system, medium scale embedded system, sophisticated embedded systems. These three are under the category of based on performance of the microcontroller. Let us discuss each category in details. First one is small scale embedded systems. First, let us understand what is meant by small scale embedded system. These are the simplest embedded systems designed to perform one or a few specific tasks. They are generally built using an 8-bit or 16-bit microcontroller. Since the applications are simple, they do not require large memory or very high processing speed. These systems continuously monitor the input, process it using the embedded program stored in the microcontroller and produces the required output. For example, a digital thermometer reads the temperature sensor, process the value and display the temperature on the screen. Example for these types of embedded systems are digital calculator, digital clock, TV remote control, electronic toys, etc. Second one is medium scale embedded system. Now let us move to the second category. Suppose you want to design a washing machine or an ATM machine. Do you think an 8-bit controller is sufficient? No. These applications require faster processing, more memory, better communication, multiple input and output devices. Therefore, we use 16-bit or 32-bit microcontroller. The programming language used in this type of systems are C, C++ or Java. So next category is sophisticated or complex embedded system. Think about modern cars, aircraft, medical equipment, robots, industrial automation. Can one small microcontroller handle all these tasks? Certainly not. These applications perform many operations simultaneously. Hence, they use multiple 32-bit microcontroller, 64-bit processor, high performance RISC processor, sometimes multiple processors working together. These systems collect information from many sensors, process huge amount of data in real time, make intelligent decisions, and control several devices simultaneously. Many of these systems also use artificial intelligence, machine learning, IoT, and cloud connectivity. Next, main second category is based on performance and functional requirements. So there are four categories in these types of embedded system. First one is real-time embedded system. This classification is based on how the embedded systems performs its task and the functional requirements of the application. There are four categories: real-time embedded system, standalone embedded system, networked embedded system, mobile embedded system. Let us discuss each category in detail. Real-time embedded system. You imagine driving a car and suddenly a person crosses the road. Should the airbag or braking system respond after 5 minutes? No, it must respond immediately. So this is the concept of real-time embedded system. A real-time embedded system is one of which the output must be produced within the specified time limit, that is called a deadline. So if the response is delayed, the system may fail or become unsafe. Real-time examples are traffic signal control system, airbag system, medical monitoring equipment, military defense system, aircraft system. So there are two categories in these types: soft real-time embedded system and hard real-time embedded system. In a soft real-time embedded system, the deadline is important, but a small delay is acceptable. Even if the task finishes slightly late, the output can still be useful. Example, suppose you are watching a YouTube video. If the video pauses for 1 second because of buffering, will the system completely fail? No. The video continues after a short delay. Therefore, this is a soft real-time system. Other examples: video streaming, online gaming, multimedia applications. So next, hard real-time embedded system. The deadline is strictly followed. If the task is not completed within the specific time, the output is considered invalid and may lead to dangerous consequences. Example, consider the airbag in a car. If it opens after the accident, is it is useful? No. It must open within milliseconds during the collision. Therefore, it is a hard real-time embedded system. So next is standalone embedded system. What happens if a calculator is not connected to the internet? Can it still perform calculations? Yes, it works independently. Such systems are called standalone embedded system. That is, a standalone embedded system works independently without depending on other computer or host system. It accepts analog or digital inputs, processes them internally, and produces the required output. Examples: calculator, microwave oven, MP3 player, etc. So next is networked embedded system. So almost every device is connected to the internet. Example include smart TVs, smart homes, smart meters. These belongs to networks embedded system. A network embedded system is connected to a communication network through wired or wireless technology to exchange data with other devices or servers. Example, ATM machine, home security system, card swipe machine, and other IoT applications, etc. So next is mobile embedded system. So which embedded system do you use every day? The answer is your mobile phone. A mobile phone is an excellent example of a mobile embedded system. A mobile embedded system is a compact, portable embedded device that requires fewer resources and is designed for easy mobility. Examples: mobile phones, MP3 players, digital camera, etc. Thank you.